Hello class, this is another video tutorial on the examples of how we might use the product identities. So I have them here once again. You can pause and give these a go at any time that you'd like. So let's get straight to it. So sine 180 cos 60. I hope you can see that's sine A times cos B. That there, I hope you can see, looks just like this expression here, which is what we're going to be using. So taking this expression, it's going to become half sine A is going to be 180 plus B, which is going to be 60. There's going to be an addition there. Sine of 180 once again, because it's A, minus B, which is going to be 60. That there is just this portion shown. I'll color code it to make it a little bit easier. Let's just give this a highlight. This first part is shown here. There's a plus in between. Just so that I don't go over here, I'm going to take it into a second line here. So plus cos 180 sine 60. I hope you can see again that that is this identity shown. That's going to be half outside of sine 180 plus 60 minus sine 180 minus 60. Alrighty, let's keep going here. I'll color code this again just so to make it a little bit easier for yourself later on. Okay. Now, it's a bit tricky because it's supposed to be all in one line, like so. So it should be in one line. So with that in mind, I hope you can see that they both have a half in front, which I'm going to factor out. So half outside of, I'm going to add these two. So that's going to be sine 180 plus 60 is 240. Plus 180 minus 60, so this one here, that's going to be 120. Okay, so since we factored this out, there's going to be a plus in between, and I'll take the purple writing now. So we factored out the half from this expression, plus we're factoring out the half now for this expression shown here. So it's going to be sine 240 minus, because there's that minus there, 120. Oop, not 120, sine 120, my apologies. All right. So from here, I hope you can see that this sign subtracts with this sign, so they cancel. And we get two lots of sine 240. So it's going to be half times two lots of sine 240, half times 2, and we're left with just sine 240. Now at this point, you could find the exact value for this using, I can see this as sine 2 times 120 plus 120. And you can find the exact value of sine 120, but for now, I'm just demonstrating to you how we can simplify this into something more simple, like so. So we're not quite looking for the exact value, but later on you can do that yourself. Okay, so moving on for the next question here. Let's just make some more space. Now this one looks as if it's nothing like anything shown here. So you might be tempted to do the sum of cos. So for example, cos m cos n minus sine m sine n, as in this becomes that expression. However, if you look very carefully, this looks awfully similar to, if you look very carefully, this one here. Okay, so if I just rearrange it for you, take a look. That's cos of m minus n plus cos of m plus n. So look, that's cos of a minus b plus cos of a plus b. That there looks very close. So we can actually simplify this into, well, since it's missing a half, if we just multiply both sides here by 2, so it becomes 2 cos a cos b equals that expression that we have. That looks just like what we're looking for here. So we can actually simplify this expression into 2 cos a cos b, but instead of a and b, it's going to be m and n. Okay, so that one's a little bit more tricky. Just pause and give it a moment. Just know that we're looking at this expression here, except it's missing a half, so we multiply the 2 to make it look just like what we're looking for. Okay, let's try another example here. Let's copy this and bring it down. Alright, so look again very carefully. Cos, that's this one here. So that's going to be half outside of cos of a minus b. That's 270 minus 80. Sorry, 290 minus 80. It's going to be 210. I'm going to do a bunch of skipping now. So that is going to be cos a minus b. So 290 minus 80 is 210. Plus, we're still on this expression here. Cos of a plus b, that's going to be cos a plus b is going to be 370. So we're finished with this expression. So that is that one. Now let's move on to the next half. It's going to be plus sine and sine. That's this expression here. It's going to be plus half outside of cos a minus b. That's 290 minus 80. That's cos 210 minus a plus b. Cos a plus cos plus b. So that's going to be 370 once again. From here, I hope you can see we can factor out the half, which will give me cos 210 plus cos 210. That's 2 lots of cos 210. Positive 370 plus minus 370. So these two actually will cancel with one another. That's going to be plus 0. And from here, we can see that these cancel. So half of 2 cos 210 is just cos 210. And as before, We could find the exact value of this because I can see this as cos 180 plus 30, but I'll leave that for you in another video or to answer yourself. Okay, so let's move on to the last example. This one once again looks very similar to this example here. I'll let you pause and give this a go yourself. You can pause and try and express this and find it in one of the identities here. So here we go. I hope you can see it. I can see it right there. It's going to be, take a look, that's sine A plus B minus sine A minus B. So this expression looks very close to this one. So all it needs is if it had a half on the outside, like so. But since we don't have the half, we can get rid of this half by multiplying this by 2 to make it 2 cos A sine B equals everything here. So we don't need that half anymore. So from that, I hope you can see that this expression is actually equal to 2 cos of A, which is now going to be x, 2 cos x sine B, which is going to be y. So this expression simplifies to 2 cos x sine y. So I hope that gave you an insight into how we might further apply the product identities in some examples. Hope to see you in the next video. Best of luck.